Lesson 26, Optimization number 1. A closed rectangular box of width x and depth y and length 3 times its width has a volume of 4,500 cubic centimeters. In part 1, we have to show that the surface area S is given by S equals 6x squared plus 12,000 over x. First of all, we work out the surface area. And to do that, we've got note we've got 6 surfaces, but of course it's a closed rectangular box. We take this N1 here, right? That one there's going to be x, y. We'll take the top, and that's going to be 3x times x, which would be 3x squared. And we take this front face, which would be 3x times y, which is 3xy. Now, because there's 2 of these, that side and the other side, and there's the top and the bottom, and there's the front and the back, we have to double each one of these. So the area will be equal to, this will be 6x squared plus 6xy plus 2xy, which equals 6x squared plus 8xy. You notice we've got only x's here, and there's no y's, so clearly we have to find an expression in terms of y. But we're given the volume is 4,500 cubic centimeters. Now the volume of this, V, will be equal to 3x times x times y. 3x times x times y. That is 4,500 will be equal to 3x squared y. This means that y will be equal to 4,500 divided by 3x squared. Okay, so that's going to be equal to 1,500 over x squared. So replacing the y with 1,500 divided by x squared, we get 6x squared plus 8x times 1,500 over x squared. And of course this becomes 6x squared plus, now 8 times 1,500 is 12,000, and the x cancel with this on the x's down the bottom, and we get the desired result, 12,000 all over x for part 1. Right, now in part 2 we have to find the dimensions of the box which has a minimum surface area. To do that, we'll need to differentiate this, and so we'll see that ds dx is going to be 12x minus 12,000 x to the minus 2. Now if we differentiate that again, we get the second derivative is equal to 12. Now this will be plus 24,000 x to the minus 3, or x cubed. So clearly if x is positive, if x is greater than 0, this will be positive, so we'll get a minimum provided that x is a positive result. And of course x must be positive because we're looking at dimensions here. Okay, so let's let dx equals 0. So we'll let ds dx equals 0, and we get 12x minus 12,000 over x squared is equal to 0. Just taking this up here a bit, we'll get 12x equals 12,000 over x squared. 12x cubed equals 12,000. So x cubed equals, dividing by 12, 1,000. And taking the cube root, we get x is equal to, cube root of 1,000 is 10. Okay, so we know that's going to give us a minimum because it's positive. We'll take the 10 and we'll have to put that into the y value. And if you recall that the y value previously was y was equal to 1500 or 1500 over x squared, and putting that in we get 1500 over 100, so y is equal to 15. So the dimensions to make this have a minimum surface area are x is equal to 10 centimeters and y has to be equal to 15 centimeters.